Hello everyone and welcome to Chem 1083. Today we're going to be talking about Lewis dot structures. This is going to be a very basic introduction video. We're not really going to delve into how to define the Lewis dot structures of complex molecules just yet because there's so much background that we need to understand first. Now, why in chemistry do we focus so much on Lewis dot structures? So the reason for this is because different elements in the periodic table can bind together in a specific way to form different molecules. It's like understanding how hydrogen and oxygen can come together to, form something like water. So the first thing to understand is we need to know what valence electrons are. So valence electrons are basically the electrons found in the outermost shell of an element. So if I take, for example, carbon right here, one carbon atom has a total of 6 electrons, but where these electrons are located is what varies. So we draw the center right here for now, and the first shell can only contain maximum of 2 electrons. So I have these 2 here. Now I still need to find a place to put the rest of the 4 electrons, and that's going to go in the second shell. Now the second shell can hold up to 8 electrons, so I can easily fit all 4 in here. Now if we focus only on the outermost shell, we see that carbon has 4 valence electrons. You do not consider the ones that are in the innermost. You always consider the outermost shell. Now let's just do another example. Here, let's try phosphorus. So one phosphorus atom has a total of 15 electrons. So we have phosphorus here. Again, the first shell can only maximum contain 2 electrons. So I still need to find space for 13 more. Then the second shell can contain up to 8. So let me draw 4 more. So now I've used up 10. So I need to find space for another 5, and now that's going to take place in the third shell, which can also hold up to 8 electrons. And I could easily fit 5 electrons right here. So again, only focus on the outermost shell and see how many electrons there are. So there's 1, 2, 3, 4, 5. Hence, phosphorus has a valence electrons of 5. Now the periodic table is set up in a particular way so that finding the number of valence electrons of each element is easy. So first thing you do is just number all the columns. 3, 4, 5, 6, 7, and these are the noble gas, so there's 8. So like we did the example with carbon, carbon has a valence electrons of 4, but every other element below carbon will all have valence electrons of 4. Similarly, if we look at oxygen, oxygen has a valence electron of 6, but every other element beneath that will also have 6. And similar even with the first group, lithium, sodium, potassium, hydrogen, they will all have a valence electron of 1, corresponding to the column number that they're in. Now let's get into how do we draw these dot structures. So if I take, again, carbon like we did for the first time, carbon has 4 valence electrons, and the way you draw that is, imagine that there's a box around the element. You're going to place a dot, which represents the electron, at each side of the box. Now you have to cover all the sides first before you start pairing the electrons. So something like this is not correct. Neither is something like this, because you did not fill all the sides surrounding the element. Hence, let's do another example. If we do some oxygen, oxygen has 6 valence electrons, so first always use up all the sides and then start pairing it. So I could put 1 over here and 1 over here, and that gives me 6. But I could also do it this way. I could first put 1 over here or 1 on this side. Or similarly, I could do 1, 2, 3, 4, 5, 6, because every side has an electron first, and then I started pairing. Hence, this is not correct. You will never have more than 2 electrons on a side. So this, never put more than 2. This is completely wrong. So all these 3 different versions of writing the Lewis structure for oxygen are correct.